Rationalizing the denominator containing two terms, you're going to be using something called the conjugate. Conjugate comes from the difference of squares, where you've got the same thing, only with different signs. So if I take a plus b times a minus b, you have a squared minus b squared. So if this is essentially radicals with their conjugate, square root of 7 plus the square root of 3, square root of 7 minus the square root of 3. Square root of 7 times square root of 7 is square root of 7 square root of 7, plus square root of 3 square root of 7, minus the outers square root of 3 square root of 7, minus square root of 3 square root of 3. Square root of 7 square root of 7 is the square root of 49. Inner outers add the 0, minus square root of 3 square root of 3 square root of 9, which is 7 minus 3 or 4. So notice I started out with double radicals, ended up with none. So this is a binomial times a binomial. That's how it works. Two terms, you use something called the conjugate. So in this particular instance, I have 7 over 3 plus the square root of 3. His conjugate is 5 minus the square root of 3. And 5 minus the square root of 3 divided by 5 minus the square root of 3, that's 1. So I'm multiplying by 1, but a 1 is going to serve the purpose. It keeps the original problem. So multiply by the conjugate. I get in the numerator 7 times the conjugate. Denominator, 5 times 5 is 5 squared. Inner outers add the 0, minus square root of 3 times the square root of 3. That's the square root of 3 squared. 7 times 5 minus the square root of 3. 25 minus 3, which is 7 times 5 minus the square root of 3 over 22. Perfectly good answer. I don't multiply anything through just in case something reduces out. Or you can write it using the distributive property either way. I quit while I'm ahead because it's too easy to make a mistake. So that's your example.